So 2023 ADMA Paper 2 question 11. A curve has the equation y is equal to x cubed plus 6x squared minus 36x plus 25. Find the coordinates of the stationary points. So to find the coordinates of the stationary points, all you need to know is dy dx is equal to 0 at the point of intersections. At the stationary points. So whether you are talking about the maximum, the minimum, or the point of inflection, dy dx is always equal to 0. So you can take advantage of this and solve for x and find the coordinates. Remember, we want to find the coordinates, not just the x values. So after finding the x values, you use the original equation to find the y coordinates. So let's differentiate this. Dy dx will be equal to, this will be 3x squared. When you differentiate this, you have 12x. You differentiate this, you have negative 36. And since dy dx is equal to 0, so you can put your 0 there at the point, at the stationary point. Then you have this equation. So you can either solve it like this or you can reduce it. So since these numbers are too big for me, I'll use a 3 to reduce them, since they are all multiples of 3. 3 into 0 is 0. This and that is 1. Then 3 into this is 4x. Then this and that is negative 12. So now to find the values of x, for me, I think I'll go with the factorization method, unless it fails to solve the problem. And then, so the product here is negative 12, the sum is 4, so the factors should be 2 and 6. And then, so this one must be negated, since this plus this must be this and this times that must be that. So from here you can even tell that your x will be the opposite of this and your x will be the opposite of that, but I'm not going to just do it like this. Let's just take the normal procedure to minimize confusions as much as possible. So from here we can factor out the x. And then from here we can factor out the 6, the negative 6, like this. And then we have this in common, which can be factored out. Then here we have x minus 6. So now this means either x plus 2 is equal to 0 or x minus 6 is equal to 0. So from here we can see that x is equal to there was a mistake here. I wasn't supposed to use these. These are the factors, so this should have been negative and this should be positive. So that means when we factor out x, we have a negative here, and then when we factor out positive 6, we have a negative here. So this will be negative, this will be positive, negative, positive. So that means x is equal to 2 or x is equal to negative 6. And then we know the original equation. So remember, the question is saying find the coordinates, not just the x coordinates. So to find the y coordinates, you can use this and these two x coordinates. So y is equal to x cubed plus 6x squared minus 36x plus 26. So I'll just find f of 2. So this one will be 2 to the power 3 plus 6. Then we have a 2 squared minus 36. We have a 2 and then plus 25. So I'll quickly punch these numbers on my calculator. So you have 2 raised to the power 3 plus 6 multiplied by, this is just the 4, minus 36 multiplied by 2, and then plus 25. So this will give us negative 15. So our y coordinates here will be negative 15, making our coordinates 2 comma negative 15. So these are the first coordinates. To find the other coordinates, we can follow the same procedure. Our x is equal to negative 6, and then this is the equation. So let's just substitute the equation there. This will be negative 6 to the power 3 plus 6 negative 6 squared minus 36 negative 6, and then plus 25. So to find this, I'll punch everything on the calculator to shorten the video as much as possible. So here we have, let's just call it negative 6 because we know that it will be negative anyway. So negative 6 cubed plus, this one will be positive 6 cubed again, this and that, and then this and this will be positive. So this is 6 cubed again, but let's just write it as 36 times 6, and then plus 25. So this will give us 241. So the coordinates of this point will be negative 6, 241. And then the next part is saying determine the nature of the stationary points. So to do that, all you need is d2y dx2. So when this is greater than 0, then you know that you have a minimum point. And then when d2y dx2 is less than 0, then you have a maximum point. So this is how this thing is used. So now we already have dy dx. Dy dx is this. So to find d2y dx2, you can just differentiate it again. d2y dx2, when you differentiate this, you have 6x. You differentiate this, you have 12. And then now we shall test using the x values. So the first x value is x is equal to 2. So we shall find d2y dx2 at the point where x is equal to 2. So let's substitute. So this times this is 12 plus that, we have 24, which is greater than 0. So the point 2 comma negative 15, let me just write the conclusions here. 2 comma negative 15 is, since this is greater than 0, this is the minimum. Remember, this is the minimum. I know you expect greater than to be maximum and less than to be minimum, but it's quite the opposite here. And we have an explanation for that. So now to test this one, you can simply do the same thing. So we have d2y dx2 at the point where x is equal to negative 6. So we can say 6, negative 6 plus 12. And then this times this will be negative 36 plus 12. As you can see, this number would definitely be a negative number. So this is negative 24, which is less than 0. So that makes this point a maximum. So we are done with part A. Then finally we have part B. So part B is saying the curve has an equation y is equal to 2x plus 3 cos x. Find the smallest value of x for which the curve has gradient half. So to solve this one, the gradient of this is given by dy dx. So y is equal to 2x plus 3 cos x. So to find the gradient function, we can simply say dy dx is equal to, this is a 2, and then when you differentiate cosine, you get negative sign, and then this 3 will not be affected. So once you differentiate this, remember you get negative sign this. Once you get you put a positive here, I doubt if this thing will even be solvable. And then the gradient is half. Remember the gradient is dy dx. So where you have dy dx, just put your half like this and then solve for x. And remember that when you are dealing with calculus, we don't use angles in degrees. Everything must be in radians. So you can just bring this one this side. Maybe let's just bring this on this side to minimize the negative signs as much as possible. So this times this will be 4 minus that, we have this, and then we can divide both sides by 3. So I'll just do it like this so that it's much easier to see. So we have sine x is equal to a half. So this is a well-known thing. This means that x is equal to 30 degrees. But remember, we don't use degrees in calculus. So you convert these degrees to radians. If you want, you can just punch it on your calculator and make sure that your calculator is in radians, and then your calculator will give you an estimated value of this. So our theta will be pi over 6. So pi over 6, if you are using your calculator, this will be sine inverse of 0.5, and make sure you convert this to radians. So in radians, this is 0.5 data, which is the same as pi divided by 6. As you can see, it's just the same thing. So this marks the end of this question.